Okay, everyone, thanks very much for joining. I think our in-person participants are settling down. We're only 4 minutes late. So thank you everyone for joining. I've just got a few housekeeping slides and then I'll hand over to Paul and Vishali to start the session. So I'm Eleanor O'Rourke, I'm the Director of the CMIP International Project Office. So the workshop today has been a sort of joint effort. So we have the CMIP Climate Forcings Task Team. So we've got a lot of members here and they're led by Paul Durack and Vishali Naik. We've also got our generous hosts who have let us use this really quite impressive room. So from Copernicus Climate Change Services, we've got Carlo Bontempo, Anka Brookshaw's down there, and Chris is here, Chris Goddard, and also Karen Clark, who helped with a lot of the sort of logistics in the venue as well, and the IT team who have been great. So we've also got Claire McIntosh, who's from the ESA Climate and Long-Term Action Division, which has got a very long new name. And then Bryony here is with me from the CMIP International Project Office. So just a few for the in-person participants: health and safety, fire safety. We have a fire exit here, and there's an assembly area in the car park. Obviously, don't leave the site or return to the building unless you're told to do so. We all need to sign in and out each day at reception so they know where we are. This is just a picture of the assembly areas, just so you know, but generally follow the ECMWF people. So the Wi-Fi, to connect to it, you go onto ECMWF guests, and the password is on the back of your badge. I believe EduRoam is working for those who have access to it. We're going to have tea and coffee. It will either be kind of outside in that area or in the weather room. The nearest toilets are outside in the sort of lobby area. You sort of go out the room and turn to the right, and there's male and female toilets there. And the restaurant, a number of you have been in there already today. There's going to be a group photo on Wednesday, just at the end of lunch, by the ducks. So you'll know where to find that. For networking, we've got an icebreaker reception that ECMWF are putting on for us here in the weather room tomorrow evening. We've got a workshop dinner that ESA is hosting on Wednesday evening at the Thames Lido. So we'll be leaving directly here on a coach at 7 o'clock for that. And then there's coffee breaks and lunches. These are just some of the buses, but you've all managed to get here. So I think you've succeeded in that. Now for everyone, so to the people online, sorry, I had to listen to some of the in-person dull logistical information. But all of the program and the kind of logistics and also the session recordings and the slide decks will be going on the website, the workshop website, so keep an eye on that. We'll be aiming to try and get the recordings and the slide decks up at the end of each day for people who are in different time zones. Just in terms of how we're conducting the meeting, obviously everyone needs to be professional and respectful, so there's a WCRP code of conduct if you can have a look at. Everything is being recorded and those recordings are being made public. So just remember that in terms of it will be made publicly available. And just if you had anything particularly centered on your laptop screen, there is cameras in this room. So just be cautious of that. If you're online and don't want to be seen, then please just turn off your camera. It would ideally, during the discussion and when you're asking a question and you're online, it would be great to be able to see you if that's possible. But otherwise, you can have the camera off. If you want to ask a question, can you use the raise hand feature in WebEx if you are online? If you're in person, can you just put your hand up and then we'll ask you to turn on your mic and ask your question. In the WebEx chat, if you've got problems with your sound or connectivity, then you can write question and then your question in the chat, and that will be picked up by one of us who are facilitating. Do not use the WebEx chat for kind of offline discussions, long comments, the conversations between people. There is an offline discussion document for that you can add any additional information you want to do. So please Keep the chat clear for technical issues and questions. For speakers, if you're in the room here, you can turn your mics on and off by the buttons on the bottom of the mics. Can you make sure all of your laptop cameras, microphones and speakers are turned off? Then you can join the WebEx meeting itself and share your presentation instead of having to come up to the lectern. But if you have any problems, then just sort of let us know quickly, and Bryony and I can quickly share. And that's all from me. So I will hand over to Vishali and Paul.
Turn on. Great. Okay, so thank you very much. We've got a slide deck which is in only Office. If you guys are happy to drop, that'd be great. Yes, please.
Yeah.
Great. Okay, thank you. So this first session is very much a calibration session. So if you just want to jump through the slide deck, just next one. Oh, okay, there was a previous one. This is the old version. Oh, well. The first slide was a thank you slide, just to thank you for everyone that's turning up today. Thank you to Eleanor and Bryony for organising. Thank you to everyone that's made a really significant effort to get to where we are at the moment. So on behalf of all of us, thank you very much. And thanks so much for continuing to contribute. So the workshop goals, just to try and lay out what we're trying to aim for here. So we've got this part one of the workshop, which is very much trying to calibrate where we are with the CMIP7 planning, forcing data sets, the status, etc. So looking at the current version 0 data, feedback, known issues, trying to figure out where we are and try and collect information from, yeah, thanks, the updated slides, trying to capture information from some of the modelling groups that have started to pick up these data sets and use them. And then secondarily, the second part of the workshop is very much thinking about how we can do this, going forward beyond CMIP7 on a long-term mode, and trying to really think about trying to move towards a much more sustainable framework where we can clearly articulate what we want to try and get done, but then also figure out ways of funding the activities to realise the sustainable goal. And then we've got the part two, as I said before, which is this beyond CMIP7 focus. So next slide deck, please. So this visual representation is something that hopefully will be visually something that kind of captures people and calibrates all of us. One of the things that we're trying to do at the moment is we're trying to learn by doing in iterating over these data sets before we get to CMIP7 prime time. And so what the graphic shows at the top here is that we have the concept of simulations. CMIP6 simulations are mostly done. We're getting into a situation now where hopefully there's some trial simulations that are using these new forcing data sets that are turning up, and we're identifying that as a CMIP6 plus. And then what we want to try and do is through iteration, improve these data sets and then get to what will be the V1 or version 7 of these data sets, which will then be the commencement of the CMIP7 project and the CMIP7 simulations that start with these data sets. So again, just trying to calibrate on nomenclature. We've got this V0, this kind of testing data sets, identified as CMIP6 plus, and then the goal will be to finalise these data sets for preparation of CMIP7 and the commencement of the simulations as well. And the aim of that is to try and get that done in early 2025, aspirationally kind of March or thereabouts. Next slide, please. So just the status of where we're at the moment. There's a couple of links on these slides, but just to try and summarise, we have a total of 10 data sets that are required for the CMIP7 DECK simulation. So primarily this is the PI control and the historical simulation. And you can see quite a number of the data sets in the red on the far right there have actually been made available. Thank you to everyone for getting that milestone. The anthropogenic emissions are imminent. Steve Smith's been working on those, and hopefully they'll be available very, very soon. And as soon as they are available, then number 10 data set down the bottom there, and then number 6 and number 7 will also be the preparation of those things will be able to occur as well. Because we've gotten ourselves pretty organised and far better organised than we had in CMIP6, we've actually managed to identify some early issues and fix them. And so in the right-hand side there, we've had 3 iterations of the solar forcing dataset, version 4.2, version 4.3, both which were retracted actually after the new version came along. And through the process of iteration, and calling out just to Zeb for thanks very much for helping out with this, we've managed to find quite a number of issues prior to these data sets being made available, which has been excellent, you know, learning by doing before we kind of hit a problem that that would slow people down. So you can see that that second bunch of different data sets identified there have also been basically fixed before they existed, which was excellent. There's a lot more iteration to be done before we kind of get these finalised data sets ready for CMIP7, but hopefully we can do a lot of learning by doing in the next couple of days. Next slide, please. So just as a heads up to folks, kind of hard to see here, but in the slide deck you'll see, this is what these data sets look like when they're retracted. Basically, in the text you probably can't read, but with the red bits there, it says that the data sets, the solar data sets that we found some issues with, they've been retracted, which means that you know, we've got a record that they existed. If modelling groups or other folks had picked them up and used them, then you know there's still a trace of what happened. But at the moment, we're recommending that if any modelling group wanted to look at the data sets, they update to the very, very latest version 4.4. Which Bernd and team have actually generated just recently, and this was published in the last couple of weeks. Next slide, please. So next, or the previous slide, I think. So just trying to calibrate as to where we are at the moment. We've got these again, 10 forcing data sets. This is a timeline graphic that we've been trying to update as readily as we can. In October 2024, we've got quite a number of these data sets that have been published. And the aspiration again is that early 2025, January might be a bit more aspirational in reality, but in 2025, we'll actually have these final V1 data sets that will be available for the modelling groups to pick up and then start their PI control simulations, etc. Next slide deck, please. So what we're trying to do in this workshop is this template Zeb has actually generated, really trying to understand in preparation for part 2 of the workshop, what are our dependencies in order to generate these forcing data sets. And so this is just an example that Zeb's generated for the greenhouse gas concentrations. You know, who and what are we dependent upon in order for these data sets to be generated? And it'll be great to try and liberate all that information out of the forcing data set providers, so we can then point out to agencies that are producing these observations that we have a real dependence, and hopefully these observational data sets are going to be continued to be produced over time. Next slide, please. And then also to talk about how we're trying to centralise a lot of the communication, particularly with the modelling groups. We have a GitHub repo that we're capturing a lot of information around the forcing data sets, the input from MIP7's repo, and we've started some dialogue with the forcing data set providers and some early adopter modelling groups to try and talk about some of these data sets that are now available for use. And so when we have the drop-in with modelling groups tomorrow, we really want to try and pull these discussions out of inboxes into an open forum and enable everyone to benefit from, you know, these publicly available discussions that are happening. So very much trying to centralise information in an easily accessible place. There's a URL down the bottom there, and these slides will be available as well afterwards. Next slide, please. So the other thing too was trying to make sure that we collect information about each one of these forcing data sets. So again, Vishali's kind of laid out some templates here to try and capture information from the forcing data set providers, information about these the forcing data sets that we have at the moment. We did this in a Google document in CMIP6, but we want to try and do a better job of this moving forward in CMIP7. So we'll continue to have conversations about the best way of capturing information from the forcing data set providers. Next slide, please. And the previous one, sorry. and this one here. So one of the other things that we've been talking about is to try and figure out how we join the DECK simulations with the scenario simulations, the concept of harmonizing data sets. Quite a number of the forcing data set providers are familiar with the term harmonization. At the moment, the way that we've been thinking about this is that we have a historical period that extends to near kind of real time. 2021 is a time period where the data sets become relatively stable. And then we'd have this harmonization period that begins in 21 and extends through to, say, 2025, when the scenarios would begin. So at the moment, we really need to talk about this, make sure that this makes sense across all the different forcing data set providers, particularly one of the data sets that, that sets the timing of this is the SEDS data set, the emissions inventories, because there is quite a lag between the information being captured regionally and that information then finding its way back into the data products. And so one of the reasons why we have 2021 there for the end of the historical, not 2024, is because as soon as we start getting closer to real time with the emissions inventories.
Get that. Could you try again?
Oops, sorry guys. As soon as we start getting close to real time with the emissions inventories, they become pretty uncertain, I think is probably a good way of putting it. So the concept of a provisional data set is something that Steve has been talking about, and hopefully we can have a dialogue about that as well. So one of the ways that we could capture, if modelling groups are eager to pick up these data sets that are provisional, we could capture this information in a historical ext simulation if people want to do that. But again, we can talk about this slide and how we've been thinking about trying to capture the information in addition to capturing the forcing data sets that are facilitating the simulations as well. So again, this is a dialogue topic. Next slide, please. And that's it. Yeah, okay. So we're now moving to, the updates from all the forcing data set providers. Did you want to chime in? No? Okay, good. So I think Bernd Funk was actually one of the first folks that wanted to contribute the update on the solar data set. So Bernd, did you want to grab the mic and run?
Yes, hello. So I'm going to present directly here from my window. Let me see if this works.
Yeah, Bernd, you just maybe need to make it full screen.
Yeah, that's what I try to do. Yeah, okay. Okay, so this is about the solar forcing. Just first to mention that this is the work of many. So I acknowledge here all the contributors from the various different fields, from solar physics to magnetospheric physics and climate modeling. So this is a rather large group. And coming to the status and the timeline, so the current status is that the first preliminary historical data set for CMIP6 Plus was released already in June. There have been several updates, as Paul already mentioned. The current version is 4.4, which is now already on Input Formix as well as on the Solaris HEPA webpage, which is shown here. So regarding the status of this current version, the radiative forcing, which is likely of most interest here, is stable. So we don't expect big changes towards the final version, though you never know if there might be something which will be detected in the next months or so, but we think that this should be the stable version. So regarding differences to the previous version 4.3, there has been a rescaling of the TSI and SSI by a factor of about 180 ppm, which is in line with the currently accepted TSI composites and also with the NNL1 CDR3 version, which is the basis for this data set. There are, however, still ongoing efforts in refinement of the MEE, the mid-energy electron particle precipitation, which we hope to solve within the next weeks. So I anticipate, unfortunately, that there will be a further version 4.5 before we finally slip into the final CMIP7 version. Also, uncertainty estimates are still missing. We are working on that, and we hope to include them into the final version. But well, this depends on the time constraints. So for the final historical data set, this is planned to be delivered until January next year. And regarding the future solar forcing, we plan to work on that during the next year, and at least end of next year it should be ready, hopefully earlier. So this is about the status, and just as a quick glance, just a comparison of CMIP7 versus CMIP6 solar radiative forcing. So the upper panel shows the time the time period from 1815 to 2023 for the TSI, and what is immediately clear that CMIP7 is higher by 0.6 watts per meter squared compared to CMIP6, and there's also a slightly smaller secular trend compared to CMIP6. But much more important is the spectral distribution. So if we look at the middle panel about the spectral solar irradiance, so there's a significant increase in the UV part, while there's a decrease in the near-infrared part, which has noticeable implications for climate modeling in terms of snow and sea ice albedo effects, which have to be taken into account. So this is also important for model tuning. And regarding the solar irradiance variability on a decadal scale, so the lower plot shows solar max versus solar min. There are small changes with a slightly smaller decadal variability in the UV and slightly larger in the NER. So this is everything I want to comment now. Next, tomorrow there will be a more detailed presentation on the solar forcing. Okay.
Thank you, Bern. Anyone has any questions? And so we can move on to the next data set. Okay. All right. We will follow our famous forcing table to go through that update. So Steve, are you online? We can start with anthropogenic emissions. If you wanted to say a few words on where you are in your getting the data set.
I'm online.
Perfect.
Sorry. Yeah, well, I have board data. Actually, I have a slide on this in the second system and in the second session. So more details then. But we were hoping to have the data up last week, but we found one thing to fix in aviation, so we're fixing that. And so hopefully there'll be an ESGF publication queue later this week or early next week.
Excellent. Great. Thank you, Steve. We do not have Marguerite or Guido online. Is that right, Eleanor? No. Okay. So Luis, maybe we'll move to you.
Okay. So this is the update for the land use data. Full screen. Thank you. Is it full screen now? No? Try again. There we go. Yeah. Okay. So we're providing the historical land use forcing through the land use harmonization data set, which is developed by myself and George Hurt at University of Maryland. The version 0 has been available on the Input for MIP site as of October 3rd. And that version 0 is based on the data set that we produced for the 2024 global carbon budget. So we update the land use data annually for the global carbon budget by extending it to the current year, but also going back and retrospectively correcting any known errors and incorporating any new data that needs to be introduced. So the product is provided from 850 through to 2024 at quarter degrees. There's fractional content within those grid cells for 13 different land use types. We have a new land use type that's being introduced for this data set, which I'll get to on one of the next slides. And then we also provide, so there are basically 3 files, one for the states, and then one for all the transitions between the states, and then another one for the land management data layers, such as irrigation and fertilizer. And we're keeping the format the same as that provided for CMIP6, but with the additional variables that are in there. So the resolution and everything else remain the same. The new features in the data set, so we're basing the agricultural data on HIDE 3.4, which is, I would say, not a big change from previous versions. So that was easy enough to do. HIDE has incorporated a bunch of new inputs, which will improve the data. So we have new FAO data in there, food and agriculture data for cropland and grazing land. We have remote sensing data informing changes in Brazil and Indonesia. And we have a new historical cropland reconstruction for China, which will really improve the data there. We have new wood harvest. As I mentioned, we extend to the current year, but we don't have data up to the current year. So a lot of the last 5 years are using a trend from previous observations. And I'd say between last year's version and this year's, the global differences are really small. It's around 2% for most variables, but we're seeing bigger differences in those regions where we changed the input data to really improve the representation of land use in those regions. So the next steps to get to our version 1, I mentioned we have a new land use variable we're introducing. So we're going to have plantation forest. That was a variable that was requested by a lot of groups. So we're introducing that, and we'll also have harvest and the intended use of the plantation forest, like whether it's used for wood products or bioenergy. So we're going to add that over the next couple of months, update the patterns of forest disturbance by basing it on LiDAR data from the JEDI. And there are some new management layers for afforestation, protected areas, and bioenergy crops that will be in the management layers as well. And then harmonization has already been mentioned. There'll be more on that this afternoon, but we're definitely preparing now to harmonize the land use data. And then finally, on a slower time frame, sort of post CMIP7, we are hoping to maybe make a higher resolution product for just the last few decades. And also, like we did for CMIP6, the high and low reconstructions of the historical land use for uncertainty and sensitivity studies. So thank you.
Thank you, Louise. It seems like there is a question online. Gavin has a question. Are the extensions being done independently of updates to historical changes?
So the extensions are taking the historical changes and really just extending the trend over the last 5 years forward a couple of years so that to fill in that data. So it's just a really simple linear trend extension.
Thank you, Louise. Any questions in the room? All right. Moving on to GAGs.
Thanks, Shirley. So yeah, I guess for me also, thanks to everyone who's been involved in putting together our GHG concentrations, particularly all the raw observations people who I never talk to but should more, and express my thanks to them more because they're the ones shipping flasks around the world and doing the really hard work. So yeah, our preliminary data set was published a month ago, maybe, Paul, something like that. So that's out there for people to look at. Thanks to Chris and Camilla from the Fresh Eyes team who have gone and poked that and prodded that and helped find a few little bugs in there. I think probably the highlights is the big 3 gases, so to speak. So CO2, methane, and nitrous oxide look relatively stable from CMIP6. So hopefully for modeling teams, it's not going to cause you too many headaches. There's a couple of nice bugs in there. Our CFC11 equivalence has gone very wrong, so we need to go and fix that. So we'll be doing that over the time between now and when we get our V1 out in January or so. But yeah, if there's people in the room who are running models or interested in this sort of stuff, please grab the data, please go and test it, please go and help us find the more subtle bugs, and we'll iterate as fast as we can before we freeze, whenever that ends up being.
Thank you, Zeb. Questions? Okay. We can go.
Sorry, there's a question from Gavin. Are you providing ESSC independently?
I actually don't know what the acronym ESSC even means, so I'm pretty sure the answer is no. But it might be somewhere else.
It's the equivalent stratospheric chlorine concentration. So it's what you would put into the ozone chemistry independently of running like 500 different HFCs and CFCs.
Okay, the equivalent concentrations. Yeah, so we do those. So that's one of the ones that's got a nice bug in there. So our CSC11 equivalence has gone completely haywire.
Thank you.
I think it's a factor of 2, so probably it's just a mistake somewhere. But yeah, we will be providing those again, the same as CMIP6. So I think in CMIP6 we had 3 options. So option 1 was to do all 50, which no one did. Option 2 was to use a CFC 12 maybe equivalence for everything that wasn't CO2, methane, and nitrous oxide. And option 2 was to use a combination of HFC 134A and CFC 12 or CFC 11 equivalents. And yeah, it'd be nice to actually get some visibility on who's using which options, but either of them should be fine. They're produced the same way for us, so it's not a big headache.
All right. Moving on, Tom, your stratospheric aerosols.
Okay, so I've just done a full recap of what we've done with that data set. And just like everyone, I'm working with a lot of people to produce it. So just acknowledging some of them here, and also support from the CMIP IPO and ESA. So whilst designing the stratospheric aerosol dataset, we had a few priorities in mind. So first, we wanted to cater to both emission-driven model and aerosol optical property-driven model. We wanted both our dataset to be consistent as possible. We wanted to be consistent with other MIPS, in particular the paleoclimate model intercomparison project and the volcanic forcing model intercomparison project. And I wanted to document the data set. So the first data set is the emission data set. It's essentially satellite-based from 1979 onwards. It's mostly ice core based at the moment prior to the satellite era. And then for the aerosol optical property data set, the satellite era is also, again, satellite observations, the GLOSAC data set, just like CMIP6. I should point out there was no emission data set in CMIP6, so there's no comparison to make for that. And then before the satellite era is the big change compared to CMIP6, where we entirely derived the data set from our emission data set using a reduced complexity aerosol model. So that's a quick look at our emission data set. It's now online. So I refer to it as V0 in this presentation, but online you will see it as V1.1.3 on ESGF. And so we provided data from 7050 to 2023. So each dot on this graph is a volcanic eruption. The bigger the size of the circle, the bigger the mass of SO2. As shown as a function of latitude and time, and the color bar is the height of injection, which we also provide. And so the key bias to note at the moment in this data set is that for the satellite era, we have a lot of small magnitude, high frequency eruption, but these are heavily under-recorded pre-satellite era, and that's something we are working on to fix at the moment. I will skip that slide for the sake of privacy, and I will just go on to the stratospheric aerosol optical properties. So here I'm showing the stratospheric aerosol optical depth, SAOD. So you have the global mean at the top and the latitude time version at the bottom. I'm not showing comparison to CMIP6 because I think it's done by fresh eyes a bit later, and I will also have a 10-minute presentation tomorrow where I will go into more details over it. But we do have some changes, whether it's for big eruption or small eruptions. You can notice Pinatubo is still here, hasn't changed too much because it's part of the satellite era. But for example, Krakatau in 8083, we have quite a big change in forcing. And then the other thing I think of what I would note on this presentation is that before 8050 is a very volcanically active period with Tambora and an unknown eruption in 1809, sorry, and the Laki eruption. And all of this at the moment, if you follow the same strategy as CMIP6 for the PI control climatology, will not be baked in the PI control. So more discussion on that tomorrow. And that's the list of things we are working on at the moment to go from V0, which is currently available on ESGF, to V1, which will be available in January. So we have a very long wish list you can add to it. Well, just flag a few things. So first, we have an error in surface area density and volume density, which we are fixing currently. That could be important, especially for ozone, stratospheric ozone. We want to fix that bias in pre-Saturday era small eruptions. I will talk more about that tomorrow, and I will actually ask for some input from you as a community. And we have a few other things on our wish list, but for the sake of brevity, I will leave it here and take any question.
Thank you, John.
Thank you.
Any quick questions? Nope. So moving on, ozone concentrations, nitrogen deposition, we are waiting for the primary forcing data sets to be ready. Solar we already heard. CMIP, SSTs.
Did Michaela want to speak?
Michaela, did you want, sorry.
Yes, I was here, but I'm not sure, Vaishali, why do you, should I not give an update?
No, please go ahead. I wasn't sure if you were ready and given that the data set, but yeah, please go ahead.
Okay, no, I do have a quick update also. Oh no, I thought I have here a problem with sharing my slides. Let me see whether I can do it quickly. Give it, oh no, I have to, can somebody else show my slides from the meeting? I would have to go in and out, sorry for that.
Yes, we are trying here, yeah.
Thank you, perfect. But I just say go on when it's so far. So I give a quick update on ozone and the nitrogen deposition forcings. I also would like to acknowledge the funding from ESA that we receive. Just to please go on. So these are the contributors. I'm really happy that we have a team who supports us. It's Douglas Kinnison from NCAR, David Plummer from ECCC, Patrick Jöckel from DLR, and they're also part of the APARC Chemistry Climate Model Initiative, which is always behind that effort. It's a huge effort because it's chemistry climate modeling. You know that this takes a lot of time. We have a new group here at the Forschungszentrum in Jülich who helps from the Supercomputing Center, who helps with new simulations that we do. Olaf Stein and Lars Hoffmann, and my PhD student, Zoom PDRA, Shodan Ma, who is helping with the evaluation of the data set as well. And then Dan Hubert, who provides also the observations that go that are used for the making of the ozone database. Please go on. So where are we? You know that the ozone is always at the end of the chain. We are thankful for CMIP office to have organized this round here so nicely. You might remember that in CMIP6, we were not using the CMIP6 official emission data sets because it was not ready in time. But we are behind everybody, and so we will have, we work on the first preliminary historical data sets to be released at the end of November 2024, so a bit earlier than what we what we say. So this CMIP6 Plus will be a simple extension of the CMIP6 database that is available from the input from MIPS data archive. The time period that it will be covered is 1850 to 2021. And extension will be based on the SSP 370 future scenario from CMIP6. So there will not be much change from CMIP6 to CMIP to that CMIP6 Plus, just a simple extension. We have done tests which SSP we need to use to make this extension. And we are also gathering user needs for data formatting shortcomings that were coming up in the last CMIP6 data set, and what updates that people would wish. And this is all in progress now. Then we hope that we have the PI data set, if all goes well, so the really true updated CMIP for CMIP7 DECK to be delivered by January 2025. We will, based on the new forcings that come along for the final historical data sets, to run our simulations and hopefully have them ready by May 2025. And then the future ozone forcings for multiple scenarios, they should be finalized by mid-2026. Please go on. So what are new features? Well, we will consider more accurately the user requirements. We make, or we have the intention to make our ozone now fully consistent with other forcings. As I said, that was not the case last time. We had a mix of solar forcings. We had a mix of greenhouse gases and SLCF emissions in the different model simulations that we used due to time constraints. And then we also will have a consolidated historical QBO forcing, quasi-biannual oscillation. This is a natural mode of variability in the stratosphere that we will implement this time in the stratospheric part of the models to get the real correct future forcing, and a bit more to that natural variability tomorrow. We will use 3 instead of just 2 chemistry climate models. These are the 3 that will be contributing: VACAM, CHESM, CMAM, EMAC. Then the format remains mainly the same as provided for CMIP6, about 2 degrees resolution in the horizontal, 66 levels in the vertical, and then we have a time averaging of monthly. We also, according to some user requests, we want to do also hourly surface fields, because that is important for biosphere applications. So we will try to do that as well. We do harmonize historical and future simulations. I could show you an example if I'm not run already out of time. We make use of observation using the latest methods of data science. That is though still something that we do research on. It's not, we don't really know yet how we are going to do that, because at the moment CMIP6 was only model based, and this is the version 0 basically that we also will intend to do for CMIP7. And we also go into plans for operationalization afterwards. Please go on. Should I stop here, Vaishali?
No, go ahead, Michaela.
Okay, so what is the expected changes that you can think of? So if you look at this graph, you can see that the black line is the CMIP6, the IPCC AR5 multi-model mean radiative forcing for the total ozone changes. And you can see the red dot is the CMIP5 mean. The CMIP6 that I delivered was also basically the same as the CMIP5, because our 2 models that we used were basically in the middle of the pack. CMIP6 would be the mean of all the ozone forcings with the new emissions. So the new emissions are more, you get more ozone, so you have more radiative forcing. So this is likely this step change from red to blue. That is about what you can expect from moving also into CMIP7. Yeah, that is all I wanted to say on that one. Oh, and no, an important point here is that I would like to make is if you look at the CMIP6 Plus, it will be more like the green cross here, the red dot. So do only use it for format testing and let us know if something is wrong with the format, but do not yet start your base simulations for CMIP7 with those data sets that come out in January and May. In November and January. So yeah, and then the last one, this is just harmonization between future and past. It was a problem also because we had different emission-based bases. The black one was based on CMIP5. The yellow one that we had later only was based on CMIP6 emissions. And then if you go into if you look at the gray one, that is basically what we got through our scenario simulations. But if you would have merged the black and the gray, you would have gotten a huge step change in the variability, which is obviously not right. So we had to scale it back to get the red one. So that was a problem because we didn't have the emissions over the historical past in time. This is not an issue for the future, but this is just to kind of show you why that it is so important that we have now this consolidated effort and to put all these forcings into a timeline for delivery. And that's it from me. Thank you.
Thank you, Michaela. I have a question. Brioni, could we go back to the slides, please? Maybe 3 slides back. One more back. No, actually, going front. Sorry. Yes, right there. When you say somewhere you had CMIP6 database, were you thinking of using the CMIP6 forcings to drive the 3 models?
No.
No.
So when I say, so there is always this difference between the extended and the updated ozone forcings, right? So the extended ones is basically what everybody is now already working on, but that is all new for everybody else is new.
Yes.
Cannot deliver because of the timing. We can't deliver that.
Right.
So what we have to wait for is the finalized forcings, and that goes into the updated CMIP7 then.
Got it.
The one that will come out in May.
Okay. Got it.
Make sense, Pashali?
Yes. So this initial data set is more of an extension from CMIP6, whereas the new one would include all the CMIP7 forcings, and that you would deliver in May. Or May time frame.
Indeed.
Okay.
So that's why I say that this extended version should not be used for base simulations.
Got it.
That are afterwards used in CMIP. It's really just for testing.
Yeah. Thanks. Any questions in the room? All right. Next, Paul.
So I've just realised that I didn't actually generate any slides for the SSTs and CIs, which is a bit of an omission. Sorry, everyone. But there's not really a huge amount to update on that. So in CMIP, in the previous phase of CMIP6 and before that, we're actually using an AMIP SSTs from the NOAA ISST version 2 product. That product actually ceased to be available in March 2023. And so over the last couple of years, we've been trying to figure out what the next step was. One of the first things was to try and figure out if there was an update to the HAD ISST product, in which Nick Rayner has actually just recently produced the HAD ISST version 2.4. At the moment, there's a fair bit of learning by trying to understand what is available to figure out what a replacement data set will actually be. But at the moment, apart from trying to investigate what is available and how that's going to be produced, that's where we are. The existing data set that's published into input for MIPS under the CMIP6 Plus identifier extends through to December 2022. So that then provides us with temporal coverage that is consistent with the other forcing data sets, with an expectation that the data product from beginning to end will be changing when we ascertain how to do that. The long story short is the work that's going on at the moment. There's quite a number of changes in the pattern of SST changes across different data sets. The OISST version 2 versus 2.1 is quite dramatically different, actually. And so this needs to be treading carefully to try and figure out what the best data product to replace what is now completely finished, actually, is going to be done. So it's a work in progress, and hopefully that'll be done early next year. But we do have that version 1.1.9 that is available for simulations to begin, extending to 2022 with an expectation that the data set will be changing altogether. So if there's questions, and I'm sure there's probably a question from Gavin here, but if there's questions, well, I'm happy to try and answer what I can. No questions?
No questions online? Okay, great. Thank you, Paul. Stephanie, on your status aerosol optical properties.
Yeah, thank you for giving me the word. I give a very brief update because I'm talking about Simple Plumes tomorrow a little bit longer. So Simple Plumes is an anthropogenic aerosol optical depth data set, and it comes also with CD and C perturbation factors. So you can use it to induce aerosol effects in your model. The way it is done is fairly easy. So we start with the climatology for present day. Present day means year 2005. And then we use emissions from sets, namely for SO2 and NH3, to scale the optical properties and the effects on the clouds over time. We've been working throughout the summer to update with the existing emission data, our scaling. Through this process, we identified some room for improvement in the emission data sets themselves. So there was some going back and forth between Steve, Rachel, and our team, which I hope was useful. So we're now waiting for the last update, and then we're ready to produce this data set and send it. And when I say send it, it's really small enough to send it via email. So wait for that.
Great. Thank you, Stephanie. No questions? All right. So that concludes our updates. Thank you, all the data providers.
Vishali, I think we and the task team have missed probably two things for a while. So one is Heather's got this isotope data set, which was published in CMIP6, which we keep missing off our table, which would probably, I think Heather's online, probably worth asking. And two is whether we want to talk about population at all, because that apparently is something people need, which I don't think we realized again until. That's
right. But so session 4, I think, has some discussion on population data sets. So that's when we would be addressing. Thank you for bringing it up, Zeb. And the isotope data set is Heather, right?
I think Heather's ready to go.
Okay, go ahead.
Hi, everyone. Thanks. Yeah, so the isotope data is kind of tier 2, so it's not necessarily required, although the plan is to have it ready in January for historical forcing. And then there will also be scenarios, which we also provided in CMIP6. So yeah, we have a draft of carbon 13 and we're working on the carbon 14. So we should be ready in January with the historical, and then the scenarios later next year when we have the input data.
Excellent, great. Thank you, Heather.
Thank you.
No questions here in the room. All right, now we come to the end of our updates from our data providers. Thank you so much. This has been great, and actually great connecting in person here as well since the task team began. So it's nice to make that in-person connection. And with that, we move on to updates from FEOC. So Camilla is here to present that.
So it's going to be a bit of a team effort, if that, as long as that's okay with everyone. I just have to find it. Oh God, where is it? Can you see on that list? I can share it. It's just a minute. I might be found it. It's okay, I think. Let's see if it works. Okay. Oh, why is it not? I might have to start again. It's all right on mine. So it didn't work when I did that though. Oh, I'm sorry. That one? Go back to WebEx. Oh. Here. That one. Yep. Share screen. Yeah, entire screen. Okay, cool. Thank you. Sorry. Come on. Okay, contact. That was harder work than it should have been. Sorry. Okay, so yeah, it's going to be a bit of a team effort. because there's a few different fresh eyes folk that have done the analysis for the stuff that we're presenting, and then there's a lot of other things kicking off with fresh eyes at the moment because it's all changing. Okay, so these were the fresh eyes people as it started out. So we had a subgroup, and these were all the fresh eyes people that were in that subgroup. The people that are kind of here today, but not all of us are here in person, are kind of circled on this list, but we couldn't get Armin online because of the time difference, and also Wandy isn't online, I don't think, because of the time difference. But we have got slides from both of them. And if they are here, I'm hoping that they'll just unmute and shout at me, and they'll then be able to present their own slides. Okay, cool. And then recently we've changed, or the Fresh Eyes has changed to being project-led. So we proposed 2 projects, and one project is around paleoclimate and trying to ensure the consistency between paleo forcings and modern forcings. And these are all the people that have so far signed up to that project. And then we've also got the kind of this was the work that existed before, but we've got a lot more people that have signed up to this project now, including the people that are presenting today. Although Chris, I don't think you signed up yet. So. Yeah. Okay, perfect. Thank you. Yeah, so that code should allow you to sign up to either of those projects if you're interested, or you have people in your institution that are interested. So the idea is that these projects will have a finite lifetime, and then we'll be able to get people to do more towards each of the projects. So we're going to so we haven't done anything yet on the paleo stuff. Fanny Lardy will lead this eventually with a bit of support from myself and Wandy is the other co-lead for the forcing subgroup. So the idea behind this project is that it's going to evaluate, check and list all the paleo climate forcings and identify the potential differences before the protocol papers come out. And this diagram on the left is supposed to show, and I'm sure I'm not doing this as much justice as Fanny would do it, but she is actually on leave today. But basically the idea is that not all PMIP initiatives are in CMIP. So what we want to do is maintain consistency between the PI control forcings and the paleo experiments. And the idea will be that this project will look at that. And this plot here is an example for CO2, where there's for the PMIP runs, I think it's the PMIP runs, they use a deglaciation protocol, which suggests the use of ice core data, but the modern forcings use CMIP6, which I think is based on Minehausen. So that means that those 2 data sets are perhaps not completely consistent. So it'd be good to understand what the differences are between those. So Fanny will lead that. And then we've got quite a few people now interested in joining in with that effort. So hopefully we'll have more to tell you about that soon, but that is really only just kicking off. And then there's been a lot more happened with the evaluation for modern day forcings. So these are the top 4. The top row is the data sets we've had a chance to have a look at. With the people who are looking at it. So any questions after this, they will be the people to talk to. But we haven't started analysing these other data sets along the bottom yet, mainly because we haven't got a fresh eyes person that we've identified to do it yet. But hopefully with the kickoff of the new projects, there'll be a reinvigorated enthusiasm. So we're going to start. So we're going to talk about each of the forcings that we've looked at so far. So I think Chris is going to start with the greenhouse gas evaluation. Is that all right?
Yeah, sure. Thanks.
Yeah, you good.
Cool. Excellent. Thanks. Thanks. Yeah. So I guess also, yeah, thanks to Zeb and everyone involved in putting them together for doing that and giving us a chance to have a look at them, play with the data. I'll just talk through these graphs, what they show, and then we've got some similar ones later on. So the left-hand one is looking at the concentration data. So that's like the raw data that's come out from the data that's available. And the data from 1900 through to 2015 is like the common periods between the CMIP6 and the CMIP6 Plus period. So I mean, we've ignored the data before 1900, but the end obviously is in 2015. And that data on that left bit is showing the percentage change in those concentrations between those two generations. So the change in CMIP6 Plus compared to CMIP6. And then after that vertical dashed line, so in the kind of more recent periods, that's obviously the period after CMIP6 ended. So that's the change in the concentrations in the CMIP6 Plus relative to the recent period, so relative to 2005 to 14. So that's, you know, on the left-hand side, it's a measure of the difference between the two generations, and the right-hand side is a measure of the like recent change, the trend in those concentrations. And the plot on the right is the same kind of idea, but now we've taken those concentrations and put them into the FAIR simple climate model and looked at the forcings. This is just the direct forcings for each species, so it's not like the effects kind of downstream, although we do look at ozone in a bit. And again, it's a similar picture. So the data before 2015 is the difference between them just in terms of forcing at this point, like milliwatts per meter squared. And the data in post 2015 is the trend. And so I mean, one thing to kind of say, I guess, initially on the concentrations is that they start off pretty similar in the early periods for the species which, you know, have non-measurable concentrations at that point, and then they also come together to be pretty similar by the recent periods, and then they follow different trends in the more recent past. But there is quite a bit of variability in that kind of mid to late 20th century period. So to start with this kind of the big three, the CO2, methane, and N2O. Again, like Zeb said, there's quite a lot of stability in those in the past. So those red lines on the concentration graph are very close to zero, as in 0% change between the generations. And then you can see the three different lines showing sort of increasing trends in the recent history. And then in terms of forcing, as you can see, those red lines are actually some of the biggest changes in that kind of early 20th century, because obviously even though the changes in the concentrations are small, the effect on forcing can be quite big for these species. On the right hand side, you actually can't see the lines because they're off the top of the screen for the recent change in the trend in the forcing. Again, emphasizing that, you know, the change in those key greenhouse gases is, as we would expect, the dominant kind of recent change in forcing. But you'll notice that, so one bug which we found, or one kind of issue which you know we want to look into a bit more as well, is that if you have a change, you know, of lower than minus 100%, that means that the new data is negative. So there's 6 species there where the red lines show that they're going actually to negative concentrations. So that's just, we've listed them at the top. So that's just, something which we've flagged as something which, we should look into. And that's just a mix of different species. But it should be noted, I guess, that the effect of these on the forcing is pretty small. And then I think, as Zeb also mentioned, there's a couple of species where there were kind of like sort of factored changes in the concentration. So this example, CFC 114, is very close to zero, so very close to minus 100% change in the historical periods. And this is a species which is increasing and has like a non-negligible forcing. So we'll just flag that one as one that'd be interesting to look into. And then there's just sort of some storylines, some narratives that maybe aren't completely unexpected for some of these. So HFCs having some variation in the historical, but the storyline there is that their forcing on the right-hand side is kind of increasing in the recent periods, with not much variation between the generations historically. We've got these kind of Montreal gases which are doing their various things. So CFCs mostly dropping down, especially the ones with the strong forcings. HCFCs having some increases, like associated with that drop in CFCs, I guess. And halons, a similar kind of story. But you can look at individual lines and pull out different storylines and see how they vary from generation to generation and their effect on their direct forcing. And then the F gases as well, sort of doing their own different things. I mentioned ozone, so I haven't got the concentration for this, but on the right-hand side with the forcing, the cumulative effect of these different changes in the species, some of which obviously we know are issues. So this isn't like a kind of something which will probably persist, but you get this drop in the ozone forcing in the new data relative to the old data. So yeah, that's the things I wanted to highlight. I think maybe the important things just to flag are, some species having seemingly negative concentrations in this initial data. Some species having, these anomalously kind of low, factor different concentrations. But the big three being relatively consistent and increasing in the recent period. That's what I wanted to talk about. Thank you.
Thank you. So hopefully, hopefully May is online and she can now take on this one.
Yes, thank you, Camilla. Can you hear me okay?
Yeah, all good.
Yeah, thank you. So I'm showing you the comparison between CMIP6 Plus and CMIP6 working forcing. So we have identified some key differences for the updated CMIP6 Plus forcing. So the top panel is showing you the global mean stratospheric aerosol optical depth. The black line is showing you the new CMIP6 Plus forcing, and the red line is showing you the CMIP6. So you can see that the coverage is wider. We're going back to 7050 for the CMIP6 Plus forcing, and we included several larger magnitude eruptions in this period, as you can see from the plot. So when we compare the 1850 to 2014 mean stratospheric aerosol optical depth between these two data sets, actually the values are similar. It's 0.01 for CMIP6 Plus versus 0.011 for CMIP6. If we look at the period, which we have zoomed in the second panel of the figure, we're actually showing you the period from around 1945 to 1980. So for the CMIP6 dataset, we actually have some unphysical time evolution. You can see some step-like feature in the dataset. And this has been corrected in the CMIP6 Plus. You can see the lines are all smoothed for the black line. Next slide, please. Thank you. So I also want to draw your attention to one of the example for an eruption in 1862. So for CMIP6 Plus, it shows a better latitudinal distribution of the stratospheric aerosol optical depth. So at 1862, there's a tropical eruption, Makin eruption in Indonesia. And the top panel is showing you the latitudinal distribution of the CMIP6 Plus dataset versus CMIP6 at the bottom. So you can see the distribution is much better, and we have also improved the timing of the eruption in the new dataset. So I think that's all that I would like to show you comparing these two datasets, and I think Thomas will elaborate more tomorrow on the further updates on the CMIP6 Plus. Thank you.
Cool, thanks, mate. Wandy couldn't be here today. I think it might be like 2 o'clock in the morning where she is at the moment. So she gave us some of the analysis that she's done so far. And basically, we've been setting up a pipeline on the Lawrence Livermore Nimbus, that's right, Nimbus machine, thank you. All my notes are hidden, so I can't see anything on her slides. But basically, she's done a fab job looking at some of these outliers and looking at the monthly mean signal. And she's going to look a bit in more detail at these couple that are circled at the bottom. If I don't know whether you can see my mouse, but basically there's a couple here that are quite big events. So she's going to look in more detail at those. I can't remember what the rest of the notes said. So I will move straight on to Armand's biomass burning slides. So I think he's only given me one slide actually. Yeah. So he was saying that the biomass burning data set at the moment, CMIP6 Plus, is just basically an extension. And as you can see from this slide, it gets a lot more variable in the recent time. So I think what he's hoping And what the people who use this data set are hoping is that that variability, because it appears to be underestimated in the historical, that variability can be kind of merged back in through history, and then we get a better estimate of fires. So that might be a completely revised data set in the long term. But yeah, he's sorry he couldn't be here, but any questions he's happy to take. So let me know. And those are the names of everybody if you want to contact the people who've actually done the analysis.
Thank you, Camilla. That was way better than what we did in CMIP6. So it's great to have you guys looking at the data and giving feedback. Any questions for Camilla?
Sorry, unfair given the not your slide, but in the previous slide, yeah, you were mentioning the variability at the end, and there's this huge peak just before 2000. Is that that's also quite different from what this time series looks like before? So, do you know anything about the realism of that?
I think it might be. Oh, actually, no. I thought it was. I think it's a new data set. Is that right?
So the cyan line is the new version of GFET. So that's GFET 5 beta. The red and the yellow basically are the same up until 2014. And then the red is the new CMIP6 plus, which is basically extending the CMIP6 data set. So, so there are differences first with the GFET 5. And then the variability, of course, is also different given that they're extending using different data sets.
So the data set is based on GFED 4. The difference between GFED 4 and GFED 5 is pretty significant. There's about a 60%, I think, if I remember, in like globally averaged increase, which means that this is a pretty uncertain data set, which is one of the points of trying to evaluate this. There was some the variability that was in the CMIP6 data set was something that was found to be an error, a pretty significant error actually. And if John Fasillo was on the line, he'd be able to talk about that in a fair bit more detail. I think he's actually going to speak to that tomorrow. So again, like the advantage of actually doing this review is hopefully we can find big errors and aspirationally try and fix them as quick as we can in preparation for CMIP7. There is going to be a situation that this is going to be research going forward as well.
Yeah, that's very interesting. But in a sense, I guess what I was alluding to is the fact that if you look at the pre-2000 data set, it looks very different, right? So in a sense, I was wondering whether something similar to what was reported in relation to the emissions, the sulfur emission in the stratosphere and the sampling of the small is happening here. So are we blind to what's happening in the historical period for biomass burning?
So tomorrow in session 4, I think there'll be more discussions on that from Douglas Kelly. Yeah.
A key point to note here is this is active research. And so what we're actually trying to do is we're trying to take the best estimates that we have at this moment, paying attention to what we have at the moment, and then use whatever we have best estimates, whilst recognising that there are some pretty considerable uncertainties that we're discovering as we go. Douglas Hamilton's actually presenting on this topic tomorrow, because in research that he's published quite a number of years ago, that research was highlighting that there was a pretty significant underestimate in the pre-industrial biomass burning emissions. And so what we need to do is try and figure out, what reality actually looked like. One of the aspirations was to try and collect the alternative data set alongside this one, but this is research.
I'll also note that pre-1998, the data set is based on a number of proxies, models, and so it's not really observed data set, and therefore the uncertainties. You'll hear more tomorrow.
Just a quick comment from a very quick Google. I think this is related to the spatial resolution of the underlying data that's going into GFAD5, right? That's why the variability and the estimate is so much higher. It's something that we need to resolve going forward.
All right, so we've come to our sessions. Any questions, discussions that we might want to have regarding the data sets themselves, maybe address, maybe have a plan for addressing some of these issues that have been highlighted so far?
Yeah, thanks. Yeah, really interesting to get the kind of overview of the various data sets at the current time, and the fresh eyes will be really useful, I think. So coming from a kind of a modeling centers perspective where we're planning for the fast track simulations, what's not really clear to me, so maybe it might come out in the next few days, is the kind of timings of what version we're going to be used for fast track. So I was a little bit concerned by Michaela saying that the nitrogen deposition and ozone forcing potentially not available until May next year, because many of us are planning to start our simulations at that time. So I don't know if there's going to be recommendations coming from the task team in terms of, you know, finalizing a version that all modeling centers should be using in the fast track. So that would be good to come out of this, I think.
Right, so V1 or V7 of CMIP7. So that's when, so after this initial iteration, we hope by January, February timeframe, we'll have the next versions, which will be closer to our CMIP7, recommended CMIP7 versions. And that would be true for primary forcing data sets. Ozone, nitrogen, these are the ones that will obviously take a little bit more time, and that's where we would want to know if there are a number of models waiting for them, or is it a few models, and we might have to come up with some decisions at that point to figure out ways to, you know, hasten the process. Anything that you might want to add?
Yeah, I mean, learning through the CMIP6 process, we didn't have this review period. So we've already identified some things that would be great to try and do a better job of by the fast track timeline, which is looming, you know, pretty soon in 2025. I think the reality will be that we are going to have the best that we have available. If modelling groups need to start simulations, you know, you're going to pick up version whatever it is, and there may actually be an update that comes down the pipe at a later stage. But this is going to be the situation, and also the situation we actually had in CMIP6 as well. A good news story, I think, is that the pipeline that we have at the moment with input from MIPS, for example, we've got this cogs turning where we've fixed some of the issues already. We've got more that we're discovering now that will be then highlighted to the dataset providers, and hopefully that we can try and get as many things fixed as possible. But the reality is that forcing science is actually something that's happening real time. And so what we're going to have to do is lock a version in that we're recommending, and then work with those for the groups that need to run at that point in time, with a recognition that as we find more errors, and we're going to for sure, this is what happened to CMIP6, then we try and figure out what the delta is actually between the previous version and the updated version. In CMIP6, there was an error in the Pinatubo forcing that was actually identified through the process. Most of the groups had started at the time. What we did in the AR6 timeline was actually a number of groups picked up the updated version of the data set and ran that in parallel to the CMIP6. And the good news story in that situation was that the error that data set, the forcing data set error introduced, was within the model internal variability for, you know, 5-member ensemble. So it didn't kind of matter. It was an error that we knew about, but the magnitude was pretty small. Hopefully that's something that will happen again in CMIP7, but we don't know. And so one of the aspirations of part 2 of this workshop is to try and figure out how we do this much more sustainably, because at the moment what we've gotten in CMIP6, we had forcing data sets, thank you very much, and, you know, going to go back to my research project. We need to try and figure out how we can actually turn this into a circular reference where we've actually got, you know, feedback, which then feeds back on updated versions of data sets, and we identify problems as we go. But we've never done this before. So we need to try and figure out the best way of doing it, and also prop up a lot of the folks that are doing this in pretty much a volunteer capacity, which makes it very difficult to be responsive to modelling groups that say, look, I've found this error. So that's one of the aspirations that hopefully we can try and make some progress on as well. I don't know if you want to provide more feedback to the aspiration there.
No, I think that's really good. I think probably what's probably useful for the task team then is to have kind of, because different models will need to start at different times. Some are slow and some are faster. So I think that in terms of the tight deadlines of AR7 and the fast track is key. But and I recognize, and I think it's great actually that you're recognizing this as a science in its own right, an activity in its own right, and I think that will definitely feed into future generations of the CMIP exercise. But I think it's just kind of maybe being aware of that, and maybe as we go through we can just or even have priorities for what we might want to do on the fast track timelines versus what is a longer term that we won't be able to resolve. So the biomass burning is one example there in terms of how do you put in variability through the historical, we don't have observations and that kind of thing. So we're just trying to identify what we might want to do, and having those fast track simulations versus the longer timescale might be useful.
I mean, one of the things that I'd also point out too is in the slides that I tried to put together, the concept of actually having, like, this is iteration, like it is actually iteration. I mean, the concept in CMIP6 was that the deck is a continuous project effectively. We've never done that before. It didn't happen in CMIP6, even though it was an aspiration. And so I think very much now we're kind of recognising that we have uncertainties that we're not going to be able to resolve before we get to CMIP7 fast track. Do they matter or do they not matter is kind of something that would be kind of good to try and work on. And it may matter for one modelling group and it may not matter for another one. It kind of depends on what the model complexity is. So I think, this is kind of opening the can of worms in some ways to expose a lot of the issues that we've never really systematically dealt with. It's hard. It's at the cutting edge of what we're all trying to do here. But I think we can make a lot of progress if we kind of recognise that this is an iteration and it's going to have to be. In the design of the CMIP7 simulations, as we did have in CMIP6, you've got the variant label. So the R1, I1, P1, F1. If I was a modelling group, what I would recommend is that you keep your Fs pretty well controlled. So in a situation where these forcing data set configuration, the collection is changing underneath you, you very scrupulously identify, what collection you've been using as you go. Now, that's up to a modelling group to kind of document that. Because in a situation where we had a significant change to a forcing data set because we found an error, I'd want to toggle my 1 to a 2 or a 2 to a 3 or whatever. And so we do have that granularity, but we do need to be careful about how we're doing this.
When you talk about F1, 2, 3, you're basically talking about once we've finalized the CMIP7 data set. After that, if there are issues found with some data set, that's the update then or before that?
So I need to unpeel what's happening in my head at the moment. So what I'm talking about, there are two things we need to think about here because it's changing. The forcing data set collection, we're collecting and publishing an input from MIPS. Anytime there's a change, we're trying to track that through a version number. So Solaris HEPA, good example. The solar data set, we had a 4.1 that didn't even make it live because we found an error that we needed to fix. 4.2 was live, replaced by 4.3 live, both retracted when 4.4 came out. So Bernd and his team has been really, really good at kind of finding issues internally, minting a new version and then getting those versions to replace the previous versions. All of those data sets are identified pretty clearly within the file names, etc. So if a modelling group had picked up 4.1, for example, if it was ever available, you'd know that, you're a couple of versions behind the very latest and we've got some information about what the differences were. So that's the forcing data sets and we're trying to do a better job of keeping version control on those. The modelling group use of those things, that's an altogether separate thing. So the forcing, like the variant label, again, this R1, I1, P1, F1, that's up to a modelling group to ascertain, what those codes actually mean. And so that would be the part that I'm recommending that modelling groups try and think about, which will depend on the modelling group, actually. Hopefully that clarifies something.
I have a really naive question, which is we've seen some things today that are clearly bugs in the data, and we've seen some things that are more subtle than that, and probably will take some research to solve. Do we have a functioning issue tracking system anywhere? And can the modeling groups contribute to that? And is that very clear and obvious for everybody? And more to the point, can the data providers respond when issues are raised? We consider this to be bug, you know, something we can solve, something we can't solve, because that seems like the very first thing that we need.
Yeah, so, but the answer to that question is in the slides that probably wasn't made clear enough. So hopefully Bryony can pull up the slide deck that I had together. So the answer is yes, yes, and yes, I think. Well, I mean, you know, engagement is what we need. And engagement on modelling groups and Fresh Eyes and anyone else that's looking at the data sets to start evaluating things and find issues. And then the second part would be the data set providers engaging. Zeb's already made a whole bunch of comments in a Google Doc today about issues that he's aware of with the greenhouse gas concentrations, but trying to figure out how we do that actually. So there are, yeah, so the intention has been within the Input for MIPS project, for example, we've got this Input for MIPS CV's GitHub repo. In that repo, we've got a discussion forum, and the discussion forum has already got a number of data sets that we're having active discussions about. So and a couple of other folks have actually started providing feedback on those, which...
Is this what you're talking about?
That's, yeah,
Oh,
it was up for a second. So if we go to...
I just shared something. Oh, sorry. That's okay.
So yeah, so engaging is the key point here. One of the issues that we've had in the past was email was the way things were done, and it's a really bad way of sharing information. So using an open forum like GitHub, the Input for MIPS CVs is where this is sitting in the discussion forum. You can see up the top there, it's hard to read it, but that's the volcanic data set. The second one is the landscape data set. The third one is the biomass burning data set. Further down, there's solar as well. So there are some discussions that have started happening, but we really need to formulate an engagement around this. The disadvantage of email was in CMIP6, for example, a whole bunch of modelling groups were sending emails around between one another. And if that's not elevated and put somewhere kind of public, it's really hard to try and figure out, you know, a group has solved a problem for themselves. What did everyone else do? So trying to pull stuff out of emails is the key point here.
And actually, we will present this tomorrow at the drop-in session. So that would be information shared with the modelers, the users, who can then come back to this discussion GitHub and, you know, provide feedback on that.
Yeah, I just had a comment about that discussion forum. So when I saw on your slide earlier that there was a discussion on the land use data, I was like, oh, okay. So I went and checked it out. And so there is a lot of discussion happening, but as the land use data provider, I was not aware of it. So I have not responded to any. And so I know probably whoever posed the questions didn't know to tag me. So is there a way to sort of automate that or make it so that the data providers are like in the discussion from the beginning?
Yes. So this was coming from GFDL. So Sergey was looking at the data set and provided some initial feedback. He did name you or somewhere, but maybe did not tag you. So yes, so that's a very good feedback that going forward, maybe we should provide instructions on how to give feedback and ensure to tag the data provider as well. So yeah. Thank you.
It was started 4 days ago, and it was something that we haven't gotten to yet. And so we do need to do a better job of communicating. Thankfully, we're all in the same room in the same time zone as well. So hopefully we can work out some of this stuff today and next couple of days as well.
Awesome.
Another advantage would also be if there's something that's, oh, that's an easy fix, no problem, then, you know, there'll be a new data set that's coming through, you know, version 3.1. We've already kind of identified that would be something we want to try and catch. So trying to figure out the ways of trying to do this and then keeping people up to date would be useful. If people want to then watch this repo for all the changes, they can see things happening without any emails going anywhere, which is a real advantage actually as well of using GitHub. So we're going to do the best that we can is the take home. So I'll just call out for anyone online that wants to provide some questions, feedback, wants to grab the mic. Gavin? Or if there's anyone else in the room.
I'm good.
You go, yep.
Well, I don't know if it's dangerous to push me in this direction. No, but I guess picking up from the discussion we were having before, I see two elements. One is this discontinuity that seems to happen in multiple data sets between the new generation of satellite and the early generation of satellite or instrumental record. And so how to tackle that? So that's, I guess, a common feature that is not just specific to one forcing. And the second one, which I guess you were alluding to, is the connection between research and operation to some extent. So some of these discussions are very much research topics, and we don't have an answer, or we don't have even a strategy on how to tackle necessarily. And still, we need to make progress rapidly enough. So, I mean, I'm putting my operation hat on here, and I guess I'm particularly interested in that interface to understand how should the community consider possible alternative way of proceeding to allow for faster pickup or even a prioritization of some research in some respect for the relevance this may have for productions.
So, I mean, I'd put my pragmatic hat on, I think. I mean, one of the things is that we've got a whole bunch of great folks engaged to produce the DECK data sets, these 10, maybe 11 data sets for the use in the DECK. There is going to be scenario MIP, for example, that's also coming down the pipe. And so a lot of folks are going to be pretty busy actually in the next couple of months, maybe in the next 6 to 12 months, actually trying to get all these things done. Once we then got that done, we could try and think about how we move into a more kind of continuous framework, I think. But actually trying to get CMIP7 done is the objective. I think that most of us are trying to focus on here. There is a recognition, and I think we need to make this pretty explicit, that this is research. And so we're never going to have the final answer. Hopefully we're going to be in a situation where the impacts of data sets, for example, are relatively small. But changes, are going to be relatively small, but we don't know that until we get there. So it's an awkward situation to be in, but I think, again, focusing on the delivery of the CMIP7 project, the best that we can do at this moment in time, and then thinking about how we do this better moving forward, because we're not set up to do operations or sustainable at this moment.
Gavin, go ahead.
Hi, folks. I want to kind of underline, I think it was Carlo's point just now. We have been kind of like as a community, I would say a little embarrassed at how slow we've been to be able to explain things that have been happening over the last few years. And a lot of that is related to the lack of extended simulations that go beyond 2014 or 2018. And that goes for, trying to explain 2023 peaks. It goes with trying to understand the impact of the changes in marine aerosols, the impact of Hunga Tonga. All of these things, we are being asked and tasked as a broader climate science community to provide answers for these things in relatively, not quite in real time, but in a timely fashion. And we haven't done a great job. And so one of the things that has become abundantly clear as we've talked about the updating forcings and things like that is that we do need to provide mechanisms so that this is not just a one-off and then to be repeated in 7 years' time. And this is, there's a broader understanding that that's what we want, but it's not really a question of, well, everybody's working on CMIP7, you can't be bothered to do production or operational type efforts. What we're building now, and all the groups here, we need to be building pipelines with the idea that these things can be updated in a timely fashion and then projected out in a timely fashion. And that's a little bit of a different way of working than we have done in the past, but it's going to be increasingly important. And one of the key things that I've learned from talking to people about this in recent months is how many downstream groups and operations are using what is being produced for CMIP. I was a little bit shocked to find out that the reanalyses products are using CMIP5 solar forcing, right? And so the reanalysis products, both ERA5 and MIRA2 at NASA, are using projections from CMIP5, and they haven't used any actual solar forcing data since 2008. And now they're about half a cycle out from what's actually happening. That's not sensible. The updates to the short-lived forcings that are being used in MIRA, they're using fixed, I think 2016 values that they got from somewhere. Again, not good. And the decadal prediction system at the Met Office is using fixed aerosols. And again, these are not good ways to be working. And so the updates that we're doing here, though we're very focused on CMIP7, this has ramifications through the whole climate science ecosystem. And if we need to be thinking a little bit ahead about how these products are being used and how we want to operationalize climate science, I think in a slightly more deeper way than we have done in the past, and finding ways to get timely updates, perhaps for the climate models at 6 months after the end of a year, but then updating the forecasts for various forcings in some way that is much more timely. So you have a few days to get something into a reanalysis system. You have a few weeks to get something into a forecast system, and anything that we do that is better than what is being done now, I think would reap large dividends in terms of more accurate forecasts and more easily understandable explanations of what's actually going on. So that's a kind of a general point, and I'm so impressed by everything that's being done. But I really want us to be thinking, like the first hump that we're going through here, but I kind of just thinking a little bit about what's coming up over the hill at the same time that we're doing this. Thank you.
Yeah, thanks for that, Gavin. I think that's a really key perspective. One of the things I think we could do, just as a brain dead zero thing, is communicate better. I mean, the CMIP6 forcings are an improvement on the CMIP5 forcings, and if there are communities that are using these things, but they're not identifying the fact that they are, and they're not on a mailing list or whatever, then that's a pretty easy, by the way, you can temporally extend this to 2014, and, we're going to have temporal extensions to 22, 23 in the coming months. I think those kind of things are a pretty easy lift. On the forcings task team, we actually have a number of folks that are involved. So Tim Stockdale, for example, he's engaged as a stakeholder from SMWF. If we need to extend that to NASA, to NOAA, for example, then maybe we need to just reach out and say, by the way, folks, would you like to be involved? If you don't want to be involved, maybe you want to be in a mailing list. That would be, a step beyond where we are at the moment. But yeah, you're right. I mean, the intention I think we have with this workshop is part one, get CMIP7 done. Part two, figure out how we do this in a much more sustainable way. And we actually meet as many of the needs of this growing community as we can. We need to identify our community, which obviously is a pretty good first step. But we also need to get the CMIP7 fast track done. So I think doing these things, step one, step two would be a good way of doing it, because part two is very much dependent upon funding, and how we do that is complicated across the international contributor sphere, for example.
We need to be advocating for that funding. It doesn't need to be a lot, but it does need to be sustained as opposed to and operational as opposed to research. I try and impress this upon program managers that I meet, and I'm sure everyone else is happy to do the same thing. But we really need to do it in a coordinated way. This is something that needs attention from program managers to make sure that there is a maintained stream of things going forward for multiple reasons. Thank you.
Yeah, I think super interesting comments from Gavin and Paul. I think Gavin brings up a good point, which we'll talk about a lot on day 3 and 4, I think, is what do we do looking to the future? But I think even as Paul said, just the communication to start with has been a huge one. Just like getting to know some of the users of the data through the Forcings task team has made a massive difference. It's a very brief personal anecdote, like Robin, whose name I've forgotten, from ECMWF, reached out. Hey Robin, and was like, hey, can you not update the whole time series because it's really annoying for us, and can you just give an extension? And like, as soon as you know that user, it's super easy to serve them. But if you don't know they're there, you just don't do it. And so I think that's a really good one to just increase the understanding of who we're trying to serve and what we're trying to do. I would ask an interesting question maybe to Gavin, which is there a difference between sustained mode science and operational, given that they're kind of not always the same thing? So being able to do science consistently is not the same as necessarily what we think of as operational in terms of like a way a weather service works. And that may have implications or not. And then, yeah, I think a lot of the user requirements that we've been hearing about over the last 6 months or so, talking to the people in the Forcings task team and getting to know them better, like I think we could actually serve a very, very large majority, even with what we already have, if we had the funding and time. So I think like there's a huge opportunity here, and if there's appetite for it, I think we can actually do it. But it's really understanding what we're trying to do rather than having to reinvent the wheel, which I think is exciting, because it's not as big a lift as I think it maybe feels right now.
Yeah, thanks for that perspective, Zeb. I'd actually look to the agenda, actually, just to point out something that we've all forgotten about, I think, which is identifying key data dependencies. So one of the things that is necessary in order to realise this dream, Gavin, is the fact that we need to make sure that the data sets that we depend on in order to generate these forcing data sets are actually continuous. I know series, for example, NASA's series product is something that is not going to be temporarily extended in, under a series banner, for example. Are there other data products that we're assuming is going to be available for the next 5 to 10 years that we're building a dependence around that we haven't actually advocated for with the program manager and the agency producing it to continue this, going forward? So we really need to kind of think about where we are, what our needs are our dependencies being satisfied, and if they're not, we need to fix that part while we're actually trying to turn this into a much more sustainable process. So that kind of gets us back on track with the last bullet point of, session 1. Zeb, did you want to speak to that?
No, I think the agenda sums it up pretty well where we're going. So, we can keep talking now, or we can roll on to other topics, either or.
Thank you. Well, first of all, I completely agree with what Gavin said, in particular on the fact that the forcing is not only needed by CMIP, but by a variety of users, reanalysis, decadal, seasonal, and so on. So this is, for me, an extra incentive to look beyond the CMIP7 and the CMIP cycle, and really looking at a way of operationalizing the entire setup. And yes, funding is an issue, understood, and I'm sure we are all barking in the same direction, and workshop like this one will help in aligning our barking. But I don't think actually is the only element that needs changing. So we need to find the funding that support the research side, that support the operation side, but we also need to recognize the fact that it's not just research. So there is one part that is pure research that we really don't know how to tackle and requires deep pocket to do really new research. But there is one part that is not research as we normally consider it, and is very much production. You were mentioning, NWP, weather prediction, but production in that sense. And And that's a mentality a change in mentality that I think it needs to happen within the community as well as outside the community. So it's not just the funding, and the funding is a given, it's something we need to work on, but there is a broader rethinking in the way we make this forcing available.
All valid points. And I would also say that with this workshop and having the data providers here, it's more of an education for us as well, for the modelers or the other users who want everything on regular sustained mode. Because every data set provider has a workflow which may or may not be conducive to sustained regular updates. Maybe it's more of science, or maybe part of that science is more updatable on a regular basis. So I think having this this platform, and over the next 3 days, I'm sure it's going to be a lot of learning, and from that learning, coming up with a plan.
Do you want to move on to your dependencies discussion? Got 25 minutes?
10.
Oh, 10.
12.
Okay.
11. 10.
I think we did maybe shorten it in case we needed it, but we can again go at, I think the coffee will be there at 3.
Did we want to cover any critical issues with the data set? Any plans for how we would want to update now that you've gotten some sense of Zeb, are you already planning your GHG updates with the bugs that you've identified?
Yeah, they'll be, we'll get through this week and then back on the keyboard, and then we're punching again. Yeah, so, I mean, as Paul said, there's been a whole bunch of work just making sure we get other data sets out there. Because as we all know, just even dealing with like, what format am I going to get? Is it the same as last time? Is there some bug I need to fix? Have they flipped all the axes and now all my I's are J's and J's are I's? This sort of fun and games. So I think, yeah, Paul and I have done a big lift just trying to get all of that out so that people can then make scripts and things will come out the same every time. And now it's back into data updates, I think. Yeah, we'll basically go and try and download the data and tell us, like, is it easy to do stuff? Is it a nightmare to work with? And then we can iterate. But that's, I think, the thing we're really lacking at the moment is like, even just people trying to download the data, trying to read it. Do the variable names make sense? Do you understand what it's trying to tell you? Can you get sums which make sense? Or are you double counting things, undercounting things, blah, blah, blah? It's where, as data providers, we know exactly what it looks like. Like, we know what to do with it. So we kind of need people who didn't make the stuff trying to work with it and telling us, like, this doesn't make any sense, or like, yeah, it's all super smooth, super easy.
Yeah, so I guess this might be a longer question, which will come into later sessions. But I was wondering about like notation and the R1, I1, P1 designation system and future proofing that. So if we have a situation where at the moment we have this F designator, which both is there for bug fixes and potentially for updates on the forcing divergence state, that's kind of non-ideal. Like, is it worth introducing a separate designator for the point at which history becomes future?
I'd actually go back to that original slide deck if you have me to throw it up again. Sorry. So again, try to think about this, but feedback is definitely required. And I didn't indicate the variant label, which is what the discussion was basically. But hopefully, Bryony can pull up that slide deck. And one of the challenges with the forcing data sets is that there are some particularly, and Steve Smith is on the call, so he could actually contribute more tangible information than I can on this. But with the emissions inventories, for example, they're not satellite data. They don't, get land real time kind of thing. And so when the inventories are captured regionally, they then flow into the Edgar product or Gaines or these other products that are then used as the benchmark everything's built from. And so with Steve, I think he could clarify this, but 2021 at the moment is the year in which he feels that there's enough stability in the SEDS data product in which to kind of extend in the historical period. If you go into 22, 23, 24, certainly, it's going to start wobbling around all over the place. And so this is where this slide deck has come from, and discussion is definitely warranted on this. And so the idea again is that you've got a historical period that starts in 1850, extends through to 2021, and that 2021 is pretty much locked by the SEDS data set because it's the data product that's the most sensitive to changes in time. You then have this period of harmonisation that kind of begins in 21 through, say, 24, which then provides us a connection with scenario period. Matt's over there who can speak to this, Jarmo, and a lot of the folks that are producing the forcing data sets for scenario MIP in extension to the deck. But then we'd have a situation where the scenarios in CMIP7 would begin in 22, but they would have the same harmonised data that extends through to 24 or 25, and then they start diverging beyond that point because the time steps in the IEMs are normally 5 years anyway, if I'm, yeah, okay. So that means that more or less we've got this harmonisation window and then you start diverging. To get to the F part, down the bottom there, we have the historical EXT experiment, which is notation that was in CMIP6 with the intention of saying modelling groups, if you want to run anything you like, go for your life and identify them as a historical EXT. There's an ESM hist EXT as well if you want to run an emissions mode. And that would then mean that any modelling group, if they wanted to, could go beyond that 2021 deck historical time period and run to near real time if you wanted to, with the provision that those data sets are probably going to be changing and potentially markedly as well as time evolves. So by the time we get to 2030, the 2024 period in SEDS, for example, might change quite markedly. By the time we get to 2030, the SSTs probably won't change markedly unless someone's gone and reprocessed the whole time series and found that there was a bug in the system. So it's a challenge to figure out how we do this, but I think something like what we've got up on the screen at the moment is a good thing to discuss. Does this fit the needs of the modelling groups to identify the simulations, which is simulation identities? Yes, no. Can we improve it? Are there clarifications? How do we want to go forward with this? So you're nodding your head, Ben, so feel free to contribute.
I mean, yeah, no, I mean, there's a lot of logic in this approach, but it's kind of hard coding the importance of 2021 for the entire CMIP7 generation, right? Rather than saying, in 3 years' time, we could have better data. If somebody wanted to produce another scenario which diverged at a later point in the past, you could imagine a different system where you simply had that date being a bit more free and being specified by an identifier rather than being like, this is a property of the generation of models.
Well, I mean, a point would be that the deck, since CMIP6 was always meant to be this kind of continuous thing, it was never realised in CMIP6, and even now, like, how do you actually realise that? It's really hard because unless you have a template for every single simulation to be documented against that satisfies all these things, which forcing data set did you use, etc. What's your physics configuration? What parameterization choices did you make, etc. Like, there's a huge raft of different things and decisions that modelling groups are making. One of the can of worms we didn't poke was how are the forcing data sets then interpreted and implemented by a modelling group, which is another can of worms that we need to think about. And that is something that, like, it's going to be very hard to come up with a template for different modelling groups to try and capture all that information. Does it matter? Yes or no? I don't know. But I mean, the more that we try and use these things for operations, we're trying to make like investment decisions, etc., from the CMIP output. We need to do as best a job as we possibly can with a recognition that iteration is going to be the name of the game because it's the only way we can actually make progress. So in my head, the way that I think about it is that CMIP7 needs to be locked in. We call it version 7 of the forcing data sets, for example, with a complete recognition that that is actually going to evolve. Maybe a lot. It kind of depends on the data set. And then we kind of get that job done and then think about how we kind of move forward in a sustainable operational mode. But we have a lot of pieces to identify things and to try and do a good job of communicating what we've done in model land. We just need to make sure that we come up with templates that guides modelling groups to do exactly that. So if you've got suggestions, recommendations, feedback on this kind of idea, feel free to throw it at us, because I think we need to collect, we've got a lot of different modelling groups that do different stuff, actually. And how do we best try and coordinate things so that we know what people have done, because it's going to be different across different groups.
Steve, go ahead.
Sure. I think mostly in response to Ben's question, but I wanted to distinguish that we've got the CMIP7 set up where, we need to sort of freeze things to certain dates and certain times. And I think identifying clearly, we're going to talk about this more in session 2, identifying clearly what that is, and then this, supplying historical extension data that's benchmarked to this frozen 2020 years, what we're proposing, allows essentially reuse an extension of the CMIP7 data sets. But in the future, we will be releasing more entire historical series, right? So they'll change. And so that's also there in parallel. That has nothing to do with CMIP, that of course the community can do whatever they need to with. So anyway, we will talk more about this later.
Thanks, Steve. And plenary 3 will also address just talking about what are the requirements and how to address those challenges. And I actually wanted to maybe ask a question of Paul. Is there a task team that is discussing the naming notation?
No.
R1, P1, F1? Is that notation up for discussion, or is it static and we are going to be following what we did in CMIP6?
The answer would be yes. There's a CV's task team, but the expectation at the moment is that what we had in CMIP6 suits the purposes of what we're trying to get done. And having said that, there's a notation, but there's no guidance on implementing that notation, which is the missing part, actually. I'd ping across to Ben, said, have you guys been thinking about that at all in the said TT?
About the notation, we've discussed it, but we don't have like recommendations. But we could do. That's the thing you could throw at us if you want.
Because it makes sense to me if particularly with scenarios and different choices or whatever, we need to figure out that we have enough granularity in how we identify things to be able to capture it. I think with the ESM Hist X, historical X, that's something we need to make sure that modelling groups know about it in a situation where you want to go and do something different. The way that we've actually done things like the realisation, physics, implementation, etc. Gavin, NASA GIS is one of the only group, well, there's a couple of groups that use it, but the physics identifier, how much does that change the simulation? And is that something that would be sensitive to forcing? Coming up with, kind of a best practice guide, I think, for modelling groups would be quite a useful thing to try and put alongside the forcing data sets, which then means that we try and capture this stuff as we go. My guess would be with different, say, atmospheric chemistry parameterizations or a number of different things, you're probably going to get quite a different simulation out of that. And so the F and the P, maybe even the I, might be something that we need to think about how we best identify these things and where would we capture that information. Do we have a template that would satisfy a modelling group, GIS, for example, that has used that identifier before? Do we ask them to put that in their model documentation paper? Like, where does it logically go? And can we iterate over this and then use that as a template for other groups too? We do have, with the model documentation task team, they've been thinking about this pretty concretely, but forcings is not something that they've got captured at the moment. And one of the reasons is they're trying to figure out how they can come up with a template that captures the different configurations, submodules, for example, in a model. But the forcing part about it is not actually something that I've thought about now. Now, that probably would be a good idea. We have many of the forcing data sets that are going to have an identity, a source ID that can actually, drop down box, for example, which means that you could say, this is the collection that I used. That's way better than coming up with, we used, solar, thanks, Bernard. If we've actually got some kind of quantified identity of a data set that was used, then we can figure out, okay, this subset of CMIP7 historical simulations used the ERA data set. These, we're running afterwards, and that we can do a delta that way as well. But there's a lot of granularity we have in you know, what we've got, we just don't capture that information in a templated way now. So that would be an excellent thing also to try and think about. And if I mean, to said task team wants to think about that aspect, I'd welcome that for sure.
Yeah, well, let's talk about that.
So across task team interaction on naming, notation, and whatnot.
The way I'd partition it would be think about the science use case said, and then punt back, like, you know, what the use cases are and how we want to granularly capture this to the CV's task team, which is spinning up at the moment. And as long as we've got enough granularity, then we should be in good shape. And then we'd have to dovetail with the model documentation task team to make sure we have that granularity as well. So this is an aspiration, not a reality at the moment, just to point it out.
But we should maybe make that the CV's task team, when it is evolved, is the lead of that, because otherwise it can't just happen in various different places. Otherwise it'll be completely uncoordinated. So I think we'll put that down as one of the objectives of the CV's task team. Okay.
No, it's fine. Let's go have coffee. We'll talk about it later.
Okay, everyone, we will come back at 3:30. Oh, Gavin, do you want to come in before we break for coffee?
Just a tiny postscript to what Paul mentioned. We did use the different physics and different forcings designations in the CMIP6 database, and they were almost uniformly ignored by everybody that downloaded our data, despite the fact that they are documented on our website and in our publications, which nobody ever reads. So we do need to work harder on that. Can I ask like one separate question? Every time somebody who's online goes to a meeting remotely and everybody else goes off for coffee and they all have a chat about what's happened, like generally speaking, people just abandon the online forum. Do people want to stay on the online forum and talk amongst themselves as if we were in a coffee group? I'm trying to encourage interaction at these remote meetings.
I was going to encourage you do that. And what we will do is mute the speaker into the room until the end of the break, so you can feel free to have your online coffee chat.
Can we bring?
And I will also turn off the recording for during that break.
Can we bring?
Not hot drinks.
Okay.
I was just going to respond to Gavin's comment. Gavin, I didn't ignore your Fs and your Ps. I paid a lot of attention to your Fs and your Ps. So thank you very much for doing that, because like there weren't many groups that use that. And I think we really need to encourage as much as we possibly can. If groups are actually making different decisions, then we need to A, say thank you very much for doing that, and B, also try and figure out how we pull that information from the groups and make it even more readily accessible for the analysts of the CMIP output. So if you've got recommendations, suggestions, people have interacted with you saying, like, what does this mean or whatever, please feed that back to us, because the more that we can actually capture this information in some group that's done it, the better off we're going to be, I think, in trying to template that for other groups to use going forward.
Okay, everyone, let's go for coffee now. It should be just outside the doors.